All right, so I know we already did this, but I had this bad feeling halfway through the day yesterday when I was writing this in another class period. This explanation on B, it says H is concave down because the rates of change of H are decreasing. And that's what it should say. Where I had the bad feeling, because I caught myself as I was writing it and I left it off on another one. Make sure you say H in both parts, in the first part and in the second part. Like, you have to name it and we don't say it. So just double check that that's what we did, because again, and maybe I did do it, I did it correctly in every class, I don't know. It was just one of those moments that I had, so. All right, so then I know we started over here, but we're gonna go back and talk about a little bit of this anyway. So this just defined, increasing, decreasing, whatever. But one of the most important things here is that the intervals refer to the x values, where the y values are either increasing, decreasing, or remain constant. So like I've said multiple times, we talk about y, we look at y, we write about x, right? Okay, so increasing functions, decreasing functions. Has nothing to do with rate of change. Well, I mean, it has something to do with it, but we're not talking about rate of change right here at all. So, but either way, on both of them, the input values increase because x is always getting bigger. As x gets bigger, what is happening to y? So on this one, as x gets bigger, y gets bigger. That's when the output values increase. As x gets bigger, y gets smaller. That's the output values, right? I don't necessarily need my fun chart for that. But if I have my fun chart, and I know if my function is increasing or decreasing, that tells me if the rate of change is either positive or negative. And when you are looking at just a line like we have here, then you can clearly see the positive and negative slopes. Make sense? Okay. So then concave down and concave up. All right, so we know from our fun chart and from what happens with our little slopes, if we draw our little slopes along the way, right, that when we're concave up, the rate of change is increasing, and that's what this says, concave up, rate of change is increasing. Concave down, I think we did sketch those on there, rate of change is decreasing. So that means here's what we want to write over here, that our rate of change I got to spell change right. Change is increasing the entire time because it's a parabola, right? So it's increasing from negative infinity to infinity. Right. Wow, I have a ghost back there, I guess. Oh, somebody's stapling on the other side of the wall? I must have, okay. Rate of change is increasing the entire time. The function, is the function increasing the entire time? No. When does the function start increasing? Where? Where? Is it increasing here? No, not till we get to here, right? Then it starts increasing, so 0 to infinity, and it's decreasing from negative infinity to 0, all right? So rate of change, rate of change versus the function itself. For the concave down, the rate of change is decreasing the whole time, so that goes from negative infinity to infinity. The function here, when is the function increasing? Where does it start increasing? Negative infinity, and it goes to 0, and then it's decreasing 0 to infinity, right? Everybody okay with all that? It's not 0 to negative infinity because, yes, this is going down to negative infinity, but that's the y's. I talk about the y, I write about the x. X is going to positive infinity. Okay? Everybody good with all that? Yes? Okay. Separating, are we talking about the function, or are we talking about the rate of change, right? All right, so let's look at example 7. It says selected values for several functions are given in the tables below. Determine if the function could be concave up, concave down, or neither, and justify your answer. So we're not doing that by looking at a graph right now. We have a table, which means that we need to find the rates of change. Okay. Now, on your when you're just asked, give me the rate of change, then that's when we have to make sure we use our function notation and do that correctly. Here, nobody's asking me for the rate of change, but I have to find it in order to answer it, so we can kind of skip the formalities of that. So we are just going to find the rate of change here. I like to start with my x's because they go on the bottom. So 3 minus 1, then I line it up. 8 minus 12. 8 minus 12 is a negative 4 over 2, which gives me negative 2. Yes? All right. Then y'all go ahead and find the other 3 rates of change here, because now we're going to go from 3 to 5. Okay, so we want to know if the function is concave up, concave down, or neither. So here are my rates of change. If I have to relate my rates of change to my function, what should I write down? What's going to help me? My fun chart, maybe? Okay. So since I want to know if I'm concave up, concave down, or neither, I'm looking at this part of the fun chart. This is what I want to know about the function. I have information about the rates of change. So now I look at my rates of change and I just have to decide if they are increasing or decreasing. What are they doing? Increasing, right? They're getting closer to 0 from the negative side, so they are increasing. So then I can answer this by saying H is, if they are increasing, what is H? Concave up or down? Up. Is concave up because the rates of change of H are increasing. And you want to make sure that these parts match, right? And I don't have to do the intervals right now like we did on the first thing we did, because we're just talking about parabolas right now. So they're always one or the other. I don't have a... Everybody okay with that? Any questions? All right. So let's do this next one then. Okay? Let's find these rates of change. Negative 1 minus a negative 2, and then 8 minus 11. Okay, and you just go ahead and find the rest of them. So let me continue. Let me see. Where was I? Okay. 1 minus 0, 2 minus 5. I'm sure y'all are probably done by now. Oops. And then 2 minus 1, negative 1 minus 2. Okay. All right, so here are, I'm going to box them since there's so much stuff going on here. That's a negative, even though it doesn't look like it. There we go. All right, so what do you think? Are we concave up, concave down, or neither? Neither, because they're not, the rates of change are not increasing or decreasing, right? All right, so then this is what we say. We would say, K. All right, so K is neither concave up or down because, so K is neither concave up or down because the rates of change of K are what? Constant. Good. Because the rates of change are constant, what is this graph? It's linear, okay? But I don't want to say K is neither concave up or down because K is linear, because then I have to explain how I know it's linear, and I know it's linear because the rates of change are constant, right? So you could say it's linear, but you still have to say that. So we don't need to go any farther than that. We all okay so far? Yes? Okay, good deal. So grab your second sheet of paper that you have, or the one you picked up today. This is also going on 24 when we are done. Okay, I'm going to give you 2 ordered pairs. So there's this. I know there's a little bit of space to write up here. I gave you as much as I could make fit. And what you're going to do with those 2 points is you're going to use them to write the equation of a line. I will give you 2 versions of equations of a line that you have learned. You've learned y equals mx plus b, and you have learned y minus y1 equals m times x minus x1. Now, regardless of which one you use, what do you have to find first? Slope. So go ahead and find the slope. Write the equation of the line. You can talk about it at your tables if you need a little assistance. But that is a prerequisite skill. Some of us at least know how to start. Some of us didn't even try to do the slope, so I don't really know what to think about that kind of stuff. But okay, again, writing the equation of a line, prerequisite skill, something you start in Algebra 1, and I know you do a lot in Algebra 2. Of these 2 forms of a line, So we've got slope-intercept form and point-slope form. Which one do you like the best? First one or second one? Okay, so here's the deal. The first one, y equals mx plus b, is phenomenal. If you can find the slope where it's given to you, like we could, and you are given or you can find easily or you know the y-intercept. Otherwise, it's junk, okay? Because with these two ordered pairs, you trying to find b, it's an ugly fraction. It's not always an ugly fraction, but it's an ugly fraction right now. So I gave you this one on purpose to try and show you that you really don't like that one better, and I will eventually make you a believer as long as you don't resist. When I get my slope, if I'm going to use this one, which I could see by what some of you were writing, you did this one and you were trying to get it to here. So going to give you some good news in just a minute. But when I use this one, I have to have the slope and I have to have one of the 2 points. It does not matter which one of them, okay? And really on this one, one's not better than the other. If you had smaller numbers, or like if you could pick one that didn't have negatives, like that's how you might choose. But I'm going to start with this. I'm actually going to do both of them so you can see what they are. But we're going to do this one. So this y minus y1, I'd have y minus y1, which is 5, equals the slope times x minus x1, which is 1. That is in point slope form. That we should have done in Algebra 2 some and stopped right here. There is absolutely no reason to distribute. Well, the reason you distribute and do all that is to get it into y equals mx plus b. We're not doing that. We don't care. All we're going to do here, I don't care how easy it is to distribute, all we are going to do here is move the number that's on the left to the right and get y equals 5/6 times x minus 1 plus 5. That's it. That's your equation of your line. And you stop, okay? Even if it's easy, because if it is, sometimes it is easy to go through and put it in y equals mx plus b, but if you go farther and you make a mistake, then you're not getting credit when you could have stopped here. Now, if I used the other point, then it would be, so this would be like or, y minus 10 equals 5/6 times x minus 7, which would give me y equals 5/6 times x minus 7 plus 10. Right. And those two equations look like they are of completely different lines, but once you multiply everything out, it ends up being exactly the same. Okay? But no reason to multiply it out. This one is where it's at. This is what we're interested in. This is what we're interested in here. This is what we're interested in calculus. This is what we're interested in if we happen to be given a lot of stuff, which rarely happens anymore, right? We're not really given anything anymore. We all good on that? Okay, so that's a quick review. If you feel like that's all new knowledge and you have no idea what I just said, that's a huge problem. Okay, let's look at finding the equation of the secant line. All right, so we have this function over here to the right, and they gave us the equation. We want to find the average rate of change, which just screams slope, from -1 to 3. Okay? So I'm going from -1 to 3, which means my x's are 3 minus a -1. This is g. G of 3 minus g of -1. Now, how can I find g of 3 and g of -1? The graph. Right? I could substitute them in, but I can get them off the graph also, right? Unless it's like in a weird spot. Let's see. When x is 3, oh, that's good. Y is right there. When x is -1, y is right there. Okay, beautiful. So then, what is g of 3? 4. Minus g of -1, which is -4, over 3 minus a -1, which is 4. So this gives me 8 over 4, which is 2. Everybody good with that? All right. So now we're supposed to write an equation of the secant line that contains these 2 points. All right. Well, we just figured out that g of -1 is -4, and g of 3 is 4. So we actually have our ordered pairs then. All right, so go ahead and write an equation of the secant line. Okay, you did not necessarily have to write them both. I wrote them with the first one being most likely what you would pick. Like in this case, since I have a choice between the two and I'd only have to do one, I would definitely pick this one because then I wouldn't have to worry about my negatives. You can't always avoid negatives, but if you can avoid them, go ahead and avoid them. And this is what you would get. If you do end up with some negatives, just make sure that you handle them correctly. This one, they'd be pretty easy to distribute and keep going, right? But don't. It doesn't matter. Stop. Teach yourself to stop. Okay? Everybody okay with all that? We good? All right, and then it says sketch the secant line on the graph at the right. So going through those points, and there you go. Okay. Any questions? And then you can look at your line. I mean, if you have the graph, you're like, okay, well, that line is definitely a positive slope. It looks like it's about 2. I feel it doesn't tell me I'm for sure right, but if that was a negative number, I'd be for sure I was wrong. Any questions at all? All right, so let's look at 9. Average rates of change of h of x over this interval is 18. Find the missing value on the table. All right, so I'm going to start with average rate of change from 0 to 4. That means this is 4 minus 0. H of 4 minus h of 0. Okay. Set it up with my function notation. I don't know h of 4. That's actually what I'm trying to figure out. Minus, what is h of 0? 2. And then 4 minus 0 is 4. Now, what can I set that fraction equal to? What is it equal to? Reread the question. 18. The average rate of change is 18. Is means equals. This equals 18. Now solve for h of 4. If you're always waiting for me to do everything, you're not going to learn anything. What would you do first here? Multiply by 4, good. And so I'm going to get h of 4 minus 2 equals, what's 4 times 18? 72, right? So then h of 4, 74. Okay. What questions you got? We all good? All right, great. Okay, so you need your calculator, so grab your calculator so that we can do this next part. When you turn your calculator on, well, actually, yeah. Well, you're still getting it. So while we're getting our calculators, let's go ahead and read this. Suppose the demand for a product can be expressed as this function, where x is given in units of 1,000. We want to find the average rate of change of demand when the number of items increases from 2,000 to 4,000. All right? Now, just because I see 2,000 and 4,000 does not mean that 2,000 and 4,000 are the numbers that I write down, because it says given in units of 1,000. Okay, so if I have 1, it's 1,000. So when I up, this is going to be 4 minus 2, not 4,000 minus 2,000. And then P of 4 minus P of 2. So I have to have that written down. Okay. Then, when you go to your calculator, you're on the black screen, 1 for new, then no. We're going to add a calculator, and Control Doc, we're going to add a graph. And then in F1, we are going to type in that equation that they gave us. The 0.2x squared plus 1.15x plus 5.4. And then double check that your numbers are right. And then we hit enter. Okay. And then this is one of those times where, great, I have a graph. I don't really care about the graph itself. I just needed the function to be stored in the calculator, and that's where you put it. Okay. So then I'm going to go to my calculator screen, Control left, and I'm here. And I want to put in this almost exactly like what I have, except that I don't get to use p. Where did we put that function? F1. Good. So I want to get a fraction, Control divide, and then I'm going to type F1 of 4 minus F1 of 2 over 4 minus 2. And we get 2.35. Okay? Everybody okay with that? All right. So 2.35. Now, again, if I'm supposed to be correct at 3 decimal places. It gave me exactly 2, so I only put 2. I know it didn't round it for me because of the way we have our settings. So my answer is 2.35. Okay. Next, we're supposed to write an equation of the secant line with this slope and these 2 points. Now, I don't know what P of 2 and P of 4 are because the calculator did all that for me. Do I need both of these points to write my equation? No, I don't. So I'm just going to pick one. Let's just pick the first one. Why not? So in order for me to do this, I need to know what P of 2 actually is. So if I go back to my calculator, and I can just do F1 of 2, I can evaluate that, and I get 8.5. So my ordered pair is actually 2, 8.5. That makes sense? Now use all that information and write the equation of the secant line. Now, would you want to have to make this into y equals mx plus b? I don't think so, right? And you can actually just jump and write this first and put the 8.5 over there. That's okay. I just don't want to lose anybody. I'm just kind of showing you that's what I know you learned, and then that's what we're going to do. Okay? Everybody good at this point? Any questions? All right, so we're going to stop here for today. And then all that should just still be stored in your calculator tomorrow when we finish this up.